Hello viewers, in today's class we are going to evaluate this integral. So here we have to evaluate the integral that is from 0 to 2 pi, and here we have the absolute value of sine x over 2, right? And here we can see that the integrand is an absolute value function, that is the absolute value of sine x over 2. Now let us see how we can evaluate this integral by using the concept of mod function and the sign convention of trigonometric functions in four quadrants, right? So before applying these concepts, let us first make use of the method of substitution. So let us first call this integral as I, right? Now here first we'll make use of the method of substitution. So let us take theta is equal to x over 2, right? So that x is equal to 2 times theta. Now let us differentiate x with respect to theta. So we have dx over d theta is equal to d by d theta of 2 theta, and this is 2 times the derivative of theta with respect to theta, that is 1. So we have 2 times 1 is equal to 2. So now we can write dx is equal to 2 times d theta, right? Okay, now let us change the limits. So here x varies from 0 to 2 pi. The lower limit is 0, the upper limit is 2 pi. So when x is equal to 0, the value of theta can be obtained from this relation. So theta is 0 over 2, that is equal to 0. And when x is equal to 2 pi, then theta is given by 2 pi over 2, and 2 and 2 get cancelled, so we have theta is equal to pi. So now when x varies from 0 to 2 pi, then theta varies from 0 to pi, right? So now we can express this integral in terms of theta. So now we have theta is equal to 0 to theta is equal to pi, and here we have mod of sine theta, and for dx we can now write 2 times d theta. Now we can take this 2 outside this integral sign, so we have 2 times 0 to pi, and here we have mod of sine theta and d theta. So now we have to evaluate this integral, right? And here we can see that the value of theta, it goes from 0 to pi. Now see, here we have the four quadrants, that is first, second, third and fourth. And here we have 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and here we have 2 pi. Now here we have mod of sine theta, and from trigonometry we know that sine theta is positive in the first and second quadrant, right? So here sine theta is positive, here also sine theta is positive, right? And in the third and fourth quadrant the sine function is negative, right? So now let us quickly see the definition of mod function. Now see, a mod of p is defined as positive p whenever p is greater than 0, and mod of p is equal to 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0. Now if we take p is equal to sine theta, then a mod of sine theta is given by positive sine theta whenever sine theta is greater than 0. And we can see that from the sign convention of sine theta in the four quadrants, that is sine theta is positive, that is sine theta is greater than 0 when we go from 0 to pi, right? So when we go from theta is equal to 0 to theta is equal to pi, then sine theta is greater than 0. So when theta belongs to the interval that is 0 to pi, then mod of sine theta is positive sine theta. And for other values of theta, that is from theta belonging to this interval, that is from pi to 2 pi, that is when theta lies in the third and fourth quadrant, then sine theta is less than 0, that is sine theta is negative. So we'll use only this part of the definition. So mod of sine theta is equal to positive sine theta. So now this integral I can be written as 2 times the integral from 0 to pi, and mod of sine theta is positive sine theta, and here we have d theta. So here the limits of integration are from 0 to pi, that is we have to restrict ourselves to this that is the first and the second quadrant only, right? So when theta it varies from 0 to pi, then mod of sine theta is positive sine theta. So now the integral of sine theta is simply minus cos theta, and the limits of integration are from 0 to pi. So now we can take this negative sign outside, so we have minus 2 and cos theta, and the limits of integration are from 0 to pi. So now substituting the limits and taking the difference, we have first cos pi, then we have cos of 0, and here we have cosine pi is minus 1, cosine 0 is 1. So we have minus 2 times minus 1 is minus 2. So minus 2 times minus 2 is plus 4. So the value of this integral is equal to 4.